that concludes all of the material that I want to have the second exam over. The second exam is going to be entirely take the derivative of this thing. I will say, have a function, find its derivative.
No cost.
I can put cost and profit stuff on there. I can. It doesn't fit really thematically in with everything else.
Yeah, we've been hitting really derivatives too.
Yeah, it's going to be derivatives. We should feel, we are responsible for that material. I might sneak it in on the third exam, because the third exam is all application stuff. But the second exam is going to be, here are a bunch of functions, find their derivatives. There won't be any concept stuff on there at all. I just need you to be able to do the nuts and bolts of taking derivatives. Add these functions together, multiply these functions together, divide these functions together, shove one function inside of the other one. What are the derivative? What happens to the derivative on account of that? So we have three types of function in general. Now we have power functions. We have exponential functions, and we have logarithms. These are the three basic functions that we have, and so you should be familiar with their derivatives. So for example, examples of x to the n are x squared, x cubed, right? X, square root of x, which is really x to the 1/2. 1 over x squared, which is really x to the -2, right? There are some of these power functions that are really in disguise. Exponential functions, the exponent has the variable. So 2 to the x, e to the x, 3 to the x. You should know how to differentiate these types of functions. And logarithms, things like log of x, natural log of x, log base 2 of x. What's the base here? Log base 2 of x is base 2. Natural log of x is base e. And log of x is base 10. This is the base, the common log, it's base 10. Base 10 because we have a decimal system, right? Yeah.
So those x's become the exponent when you change, when you essentially translate it for the log. So
yeah.
Log base 10 of x would be 10 raised to the x.
If I had something like y equals log base 10 of x, that's the same thing as saying 10 to the y equals x. But I don't have to reinvent the wheel here, right? I can just say something like y prime is 1 over x times the natural log of 10. This natural log of 10 is in the denominator. This is the rule that we developed just earlier today. And the natural log of 10 is just some number. It's a number that's a little bit bigger than 2. I think. Sure. Yeah, I'm gonna say that. Yeah. I don't think it's as big as 3. I think it's somewhere between 2 and 3. I could be wrong there. No. All right. Sorry. How do I know it's between 2 and 3? How do I know it's about that big? What is the natural log of 10? I punch it into my calculator. Like, how do I, like, it spits out some number. What does that number represent? I'm talking about logarithms today. the natural log of 10 is the number that you would raise e to the power of in order to get 10. Right? So natural log of 10 is asking us a question. It says 2.718281828, blah, 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 right? 2.7 raised to what power is 10? So I have a number that's bigger than 2, but a little less than 3. 3 squared is 9. So 3 to the second power is almost 10. So 2.7 to the second power is almost 10. But 2 to the third power is 8, which is still less than 10. So that's where I'm thinking like, all right, well, how big is 2.7 really? Right? 2.7 is between 2 and 3. 3 cubed is 27, which is huge. If I'm shooting for 10, I've missed it by a lot if I go all the way to 27. But 2 cubed is 8, which still isn't quite all the way to 10. So, yeah. So how big is 2.7 really? I think it's big enough that that if I cubed it, it would be bigger than 10. So I'll bet that the natural log of 10 is 2 point something. This is a valuable question. Even though it's a basic algebra type of question, right? Because we are going to like see answers, right? This might be something that I evaluate at a specific value of x. And then I have to ask myself, does this answer make any sense, right? If this logarithm is mapping something like bacteria population or deer population, and I'm interested in that population, this y prime is going to tell me how fast that population is growing. And so when I evaluate this, I'm going to get a number. And I need to know whether that number is reliable or not. Right? Did I do the math correctly? Right? I'm going to shove it through this machine, and all the cogs are going to spin, and then it's going to spit out an answer. And I'd like to look at that answer and have it at least make a little bit of sense so that I have some confidence in what's going on. So having this number sense, how big is the natural log of 10, it's valuable. Trying not to waste our time.